guys, it's Mrs. Glenn, or the Mathtuber. I feel like I need some kind of intro music for these videos, so give me some suggestions in the comments below. But we are going to do a video on solving equations. So I just have some little funny quirks down here, like find x. Here it is. And then, dear algebra, stop asking us to find your x. She's not coming back. And then finding x in a magnifying glass. And then keep calm and solve for x. So I'm going to, in this video, cover one-step equations with finding x, just using one step, which is very basic, and then multi-step equations, and then variables on both sides. I'm also going to be doing equations with fractions, which is kind of difficult for some students, and I'm going to teach you some tricks that will help you solve your equations more easily. So let's get started. First one is 3x minus 5. So this is a multi-step question. So what I like to do, the first thing, is I like to put the signs of what either positive or negative in front of anything that does not have a sign. So this is a positive 3x and this is a positive 30. And that is going to help you later on when you're trying to add and subtract and do inverse operation. So inverse operation, just to start, looks like this. And what it is the opposite, so inverse just means opposite, operation. So when you think of the four different operations, you have multiplication, you have division, you have addition, and then you have subtraction. The opposite of multiplying is division. The opposite of division is multiplication. The opposite of subtraction is, addition is subtraction. Sorry, Freudian slip there. And the opposite of subtraction is addition. So to do that, what you're trying to do is to get 0 on one side so that you can move it over to the other. And you'll see why that's important. So my first step is to put your symbols in front of your signs in front of all of them. So this is a negative 5, this is a positive 3x, and this is a positive 30. So the second step I like to do is actually make shapes around like terms. And terms just mean the entire the entire part of the equation. So for the example, this is a term. I'm just going to put a box around it so you know what I'm talking about. This positive 3x is a term. This negative 5 is a term by itself. And this positive 30 is a term by itself. So you can only combine these two together because this is a number that's by itself and this is a number by itself. This number with a variable is now something totally different because you cannot combine this 3x with a 5 and get negative 2x because these are two unlike terms. This does not have an x on it, so you cannot combine it. So you are only able to combine things that have the similar ones. So this helps by putting shapes around it. Sometimes you use triangles if there's more than one variable. I'll make, like, if there's a y variable in here, I'd make the y variable triangles. Whatever, helps you. It doesn't matter as long as you keep the same type of terms, the same shape. So that is the second step. The third step is I like to draw a wall. And that's separating my left side of my equation from my right. So the left-hand side, you have to determine which side is going to be your variable and which side is going to be your number side. I like to always look to see where the variables are to begin with. So the variable is on this side, so I'm going to make this side be my x side and this side be the number side. If my program will work for me. Okay, there we go. So this side will be the number side. So that means I have to send all of the numbers over to that side and keep all the x's here. So the first thing you're going to do is you're going to actually do your adding subtracting first, which is opposite of PEMDAS, which is parentheses, exponents, multiplication, division, and then addition and subtraction. You're going to start with addition and subtraction first and then work your way up to the top. So starting with addition and subtraction, the first thing you can do is you can get rid of your negative 5. And remember, the inverse of subtraction is addition. So we're going to add 5 because that will make this 0. essentially getting rid of that negative 5. And if you do it on one side, you have to do it on the other. So that is pretty much the rule for inverse operation. You just have to do the opposite and do it to both sides. So then you're going to get nothing here. These cancel out. And bring down your 3x, because we have not done anything with that 3x yet. So we're just going to bring it down to the next line. So you're just working your way down slower and slower, and eventually this is going to turn into like an upside down pyramid and get down to x equals something. So 30 plus your 5 is 35. And then the inverse, right now these two are multiplying each other. 3 times x gives you 3x. So to get rid of multiplication, you're going to divide. And we're going to divide by whatever is a number, because remember, this side is your numbers and this side is your variables. So you're going to divide by 3, and if you divide on one side, you got to divide on the other. Remember the rule for inverse, the opposite, and do it to both sides. So 3 divided by 3 cancels out, leaving you with x. I am getting a phone call, which I just declined. And 35 divided by 3 is 11.66 repeating. So that is x. And if you were to go and try to put it back into the problem, you have 3 times x. So let's just write this over here. 3 times x, which is 11.66 repeating, minus 5 should equal 30. And if you put that in your calculator, 3 times 11.66 repeating is 34.99, and when you subtract 5, you get 29.99 repeating, and because this is repeating x6's, it is ending up to be 30. So we are correct. So let's move down to the next problem. And it is negative 7b equals negative 98. So this is actually a one-step equation, because you only have to do the inverse operation, which is the opposite of multiplication, because remember, when a number is standing next to a variable, these two are multiplying. And let me show you what I mean by that. If we were to separate those two, so we have negative 7, and then multiply it by b, you would write it negative 7b. You can't combine those two because they're two unlike items. The number is a number and a variable is a variable. We can't combine them two unless we know what that variable stands for. So we just put them next to each other. So that's negative 7b equals negative 98. So, well, draw our wall. And this is a variable. So we have a negative 7b. And this is a number. So we cannot combine those two by subtracting or adding. But we can divide by negative 7 to get b by itself. And if we do it on one side, we have to do it on the other. These cancel out, and you're left with b. So you're going to bring down b. Oh my goodness. I am getting a phone call at the worst time. All right, there we go. So, and then you're going to divide negative 98 by 7. I think it's 14, but let me just... Negative 98, yep, it's 14. So these two negative numbers cancel each other out, so it's just a positive 14. So your answer for this one is b equals 14. But if you plug it back into your equation, your original equation, to check your answers, you have negative 7, plug in 14 for b, equals negative 98. And if you multiply negative 7 times 14, you will get 98. So that is correct. So let's move down to the next problem. We have 4c minus 6 equals negative 2c plus 7. Now this is variables on both sides. So this one gets a little bit more complicated. Not too much, so don't freak out or anything. But you have a couple things going on here. So we have 4c. Let me change the color so you can see what I'm doing. All right, so I like to put in my symbols, or my positive or negative. So this is a positive 4c. This is a negative 6, this is a negative 2c, and this is a positive 7. So let's put our boxes around the variable terms. So positive 4c is a box because it has a variable, and negative 2c gets a box because that has a variable. And then I'm going to put a circle around anything with just a number, because those are separate. You cannot combine them because they're not like terms. Like terms. Get used to that phrase. All right, so we're going to combine anything that has boxes and anything that has circles with circles. All right, so first thing I like to do, and I was talking to you guys in class about this today, you don't really want to have a negative variable in the end. You can get a negative variable in the end, but you just have to multiply by -1 to change it to a positive, which is extra work. I'm going to show you later on what that means or what that looks like. So I always like to think, well, do I want to add 2c on both sides? Would that give me a -c? Or should I subtract 4c from both sides to get a positive c? If I add 2c, that cancels this out on this side, and adding it over here, I get 6c. But if I subtract 4c, that would cancel it over here, and subtract 4c over here, I would get -6c. So adding 2c looks like the best or the easiest way. So first thing I'm going to do, remember, is to draw my wall. And second thing I'm going to do is decide which side is going to be your variable, which side is going to be your number. Well, if I add 2c to this side, and I add 2c to this side, now my variables are gone on that side. So this side's going to be your c's. Whoop, don't do that. This side's going to be your c column. I'll just put it down here. And this side's going to be your numbers. All right? So these cancel out, and you're left with 7. So we're going to just put 7 down here. Equals, and 4c plus 2c. Remember, this had a box around it, so we can continue putting those or combining like terms. So 2c plus 4c gives you 6c. This does not have any circles with it, so we're just going to drop it down. And I did not line that up. Oopsie. All right. So we got 6c. Why did you change colors? Oh, my goodness. All right. Is it red again? There we go. Geez, Luigi Pats. All right, here we go. 6c, and then drop down your -6. And now we are on this line. And so you want to get used to working line by line by line all the way down. So the next step, remember, we're doing adding and subtracting until we can't do any more adding and subtracting. So we can now move this circled -6 over and combine it with our +7, because those are two circles. So we're going to do the inverse operation, which is adding. The inverse of subtracting is adding. And if we do it to one side, you got to do it to the other. So that leaves nothing on that side. Those cancel out. And 6c comes down to the next line. Equals 7 plus 6 is 13. And then to get rid of this 6, we want to send it to the number side. You're going to do the inverse of multiplying, because 6 next to c is multiplying. So that is division, which is dividing by 6 on both sides. So c would equal, this is an improper fraction, so you're going to make it into a mixed number. Or you can make it into a decimal. So if it was a decimal, that would be 13 divided by 6, which is 2.166 repeating. Or if you're going to do a mixed number, you'd have, how many times does 6 go into 13 without going over? That's 2. 2 times 6 is 12, leaving 1 left over and 6 remaining on the bottom for your denominator. So you could write it either way, mixed fraction or a decimal. And that is your answer. Let me circle it. Whoa, that wasn't a very good circle, but we'll go with it. All right. Now for the next one, we have some fractions. Everybody gets scared of fractions. I'm really not sure why, but they're not that scary, I promise. Don't reveal the next one. No. Okay, here we go. All right, so looking at this one, I have 1/2 equals 5/6d. So you're going to draw your wall. This is a positive 1/2, which we're going to circle because it's just a number. And this is 5/6d, which is the variable term with a number. So we cannot combine these two. The only thing we can do, whenever you have a fraction in an equation, you multiply by its reciprocal. So you're going to multiply by the reciprocal. And a reciprocal just means you're flipping it around. So if it's 5/6, you're going to flip your denominator with your numerator and make it 6/5. So you're just changing and flipping them around. So the reason why you do that is because these are multiplying, but dividing by 5/6 is the same as multiplying by its reciprocal. So we're going to multiply by 6/5, because that's flipping our 6 to the numerator and our 5 to the denominator. And if you do that on one side, you have to do it on the other. And so that gives you, let me rewrite that a little bit better. It's like kind of confusing. There we go. All right, so then these can cross cancel, and you're left with D. So we're going to bring it down. And when you're multiplying fractions, you go straight across. So 6 times 1 is 6, and 5 times 2 is 10. We can reduce those both on the top and bottom by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. So D equals 3/5. And if you put this back in here, 5/6 times 3/5 should equal 1/2 to see if we got it right. So 5 times 3 is 15, and 6 times 5 is 30. And if you reduce these both by 15, you get 1/2. So we were right. Woohoo! And we never went back up and checked up here. So let's go back up for a second. Okay, let me change the color. If we were to plug C back in, let's use the decimal version, it'll be a little easier. Back in for all of these, we'd have 4C. Oops, not the C. The ocean. Just kidding. Okay, 4 times 2.166 repeating minus 6 equals negative 2 times 2.166 repeating plus 7. So 4 times 2.166 repeating is 8.666 or 7, 8.66 repeating minus your 6 equals negative 2.166 repeating, or negative 2 times, on this side, negative 2 times 2.166 repeating. So you have 2.16666 repeating times negative 2 gives you negative 4.33 repeating plus your 7. And negative 4.33 repeating plus 7 equals 2.666 repeating. And 8.66 minus 6 is 2.66 repeating as well. So this is correct. Now let's go on to number 5. Just wanted to make sure I checked. And that's always a good thing to go back and check your work. And if it doesn't end up being equal to that, then you can go back and check to see if you made a simple mistake. Because a lot of times, because there's so many steps with solving equations, you might make a little mistake and you might do everything correct afterwards, but because you made a little mistake in the beginning, it messed it all up. So checking your work at the end is extra time, but it does end up paying off in the end. Alrighty. So this has some parentheses in it. So in PEMDAS, you know that P stands for parentheses. So when you're solving for equations, you're actually going to work backwards, like I said before. So if we were right to Pemdas backwards, you'd have AS and then D, M, E, and then P for PEMDAS. All right, so when you're working, hold on, I just realized I should say SA. There we go. So you're going to do your subtraction and addition first and then work your way down. But if you have a parentheses in there first, you do the parentheses first, Then do your addition and subtraction. Then you may do multiplication and division. And then you'll find x. Okay? So with parentheses, we always want to handle those first. Otherwise, you're going to come up with the wrong answer in the end. All right, so we're going to do distributive property first. So 14 times 5. So you're going to multiply 14 times 5. Let me change to a color you can actually see. That might help, Mrs. Glenn. All right, so let me go up a little bit. There we go. 14 times 5, which gives you that's 90. No, 70. And then 14 times your z. Now, you can multiply and divide with variables, but you can add and subtract with them. And what I mean by before, when we were you're boxing the ones with variables and we were putting circles around them, when you're multiplying a number with a variable, you could do that. But when you're subtracting and adding, you cannot unless they're the same. So 14 times z would give you, 14 times negative z would give you a negative 14z. Then you have your 7z equals negative 33. So the first thing I'm going to do is I'm going to draw my wall. And then I'm going to put my boxes and circles around like terms. So this is a positive 70. This is a negative 14z. This is a positive 7z. And this is a negative 33. So I can only combine like things. And because these two are on the same side, I can combine them right now. So negative 14z plus 17, negative 14 plus 7 is a negative 7z. And then I'm going to bring down my 70. And I'm just going to continue to put these around here until we get a little bit more familiar with them. Equals negative 33, because I've not done anything with my negative 33 yet. So I'm just going to drop it down. So now I'm working on this second line right here. So first thing I'm going to do, remember, is subtraction or addition after I do my parentheses, which I already did. So I'm going to do addition and subtraction. So this side already has a variable on it. So let's make this our z side and this our number side. Because there's no point of adding 7z over here and then have to move our 33. We might as well just move this 170 over, and then we'll have, we're already down to this step with division and multiplication. All right, so we're going to get rid of our 70 first by subtracting, because that's a positive 70. So adding 70 to those, or subtracting 70 from a positive 70 cancels those out. 70 minus 70 is 0. Then we have negative 7z, still there. And then negative 33 minus 70 goes further negative. So that's a negative 103. And then these are multiplying, so to get rid of that, we're going to divide by negative 7. Hold on a second. Okay, never mind. You're going to divide by negative 7. And these cancel out. So you're left with z equals, and then let's see if we can put in, I don't think you can, but we'll put it in the calculator anyway. 103 divided by 7. So negative 103 divided by negative 7 gives you 14.7142857. So if you were to reduce this any further, you could make it into a mixed fraction. 7 goes into 103 14 times without going over. And that leaves 5 left over 7. So it could be written either way, 14.5/7 or 14.7142857. And that is the answer for that one. So if you were to go plug it back in, you'd have 70 minus 7 times 14 5/7 should equal negative 33. And I actually plugged it into this line because up here we'd have to plug it in twice and we already combined like terms. So this is actually simpler if you go to this line and plug it in, where the z is just by itself and there's not two different terms with z in it. So when you multiply 7 by 14 5/7, I'm going to use this decimal. So we have 14.7142857 times negative 7, which equals negative 102.99 repeating. And then 70's drop down, minus 33. And when you subtract 70 minus 102.999 repeating, you end up getting 32.99999 repeating, which is negative 33 if we were to round. So that is the correct answer. Let's go down to number 6. Don't go away. All right. Now this one's a little bit different. You're going to find x when given a shape, and we know the sum of the angles of a triangle equal 180 degrees. So we're going to make this equation equal to 180, and we're going to add all of these angles together on the right-hand side. So you have 42 plus 70 plus x. And now you're going to combine like terms. So this is a positive 180. This is a positive 42. And this is a positive 70. Surfboard. And then you have a positive x. So we're going to put a box around our variable. So we can combine these two circles first, after I draw my wall, because they are on the same side. So we don't have to move them over to be able to combine them. No, don't draw number 7. Oh, that's really delayed. Okay, so if I were to extend my line a little longer. There we go. So we can combine these first before we even start. So we have 42 plus 70, which is 112. And then we're going to bring down our x and bring down our 180. So now we're working on this line. Notice how I keep going down line by line like you're working on a sheet of paper, because it's going to help you in the end when you're trying to make sure you've included all of your steps. Otherwise, you have some up here, some down here, and it's very confusing. This is confusing in itself because there's so many steps and so many rules to remember. You make your life easier by doing line by line. Just trust me on that one. All right, so the next step you're going to do, remember we're going to do Pemdas backwards. So if we write it down, we're doing our addition and subtraction first. So this side has the variable and this side has a number. So let's make this side our variable and this side our number. So to get rid of our 112, we have to do the opposite of what it's currently doing. So it's a positive 112. So to get rid of it and make it 0, you have to subtract 112. And if we do it on one side, we have to do it on the other. Remember, that's our inverse operation rules. You have to do the opposite and do it to both sides. So these cancel out, and you're left with x equals 180 minus 112. And that equals 68. Yep. So x equals 68. Now if we were to check our answer, these three should add up to be 180. So 68 plus 42 plus 70 should all equal 180. And let's see if it does. So 68 plus 42 plus 70 does equal 180. So we are correct on that one. Now we can move down to our next problem. Actually, this is our last problem. Woohoo! Okay, so this is the area of the rectangle is 180 inches squared, or square inches. What is the measure of h in inches? So let's look at our shape here. It's like a slow-moving train. There we go. All right, so h is only this section right here, and 10 is all the way more than halfway across, and then 12 must be our base, because I know to find the area of a rectangle, it is base times height is the area of the rectangle. So our base is 12. I'm just going to plug in 12 for B. The height for this one is actually 10 times h. So it's going to be 10 times h. Actually, it would be 10 plus h. Oopsie poopsie. It's kind of late. All right, sorry. So we have 10 plus h equals, and it says our rectangle is equal to 180 degrees, or 180 square inches. So what we're going to do is we're going to do the distributive property. So let's get rid of these parentheses on the outside here. So you're going to multiply 12 times 10 and then 12 times h and solve for h. So you have 12 times 10, which is 120, and 12 times h, which is 12h, equals 180. So draw our wall, and we're first going to do addition or subtraction first. This is a positive 120, so if we put a circle around this, this is a positive 12h, and this is a positive 180. So we're going to combine like terms, so we need to, like terms. So we need to get rid of our 120 and put it to the other side. So the opposite of addition is subtraction, and we do it to both sides. So these cancel out. You're left with 12h equals 180 minus 120 is 60. Then the opposite of multiplying is division, so divide by 12. You do it to one side, you got to do it to the other. These cancel out, and you're left with h equals 5. So to check that, we can plug it back in and make this 5. So now I know this height, or the height of the entire side, is 15. And to find the area of a rectangle, it's going to be base times height. So you have 15 times 12, and 15 times 12 should equal 180. 15 times 12 is 180. So we did this problem correct. And I've been saying h as in height, but h is just a variable in this question, so I apologize for that. But you're finding h for this, so you're going to have to find what is the measure of h in inches. So you knew that 10 plus this h would be your base of this rectangle, and 12 was your height. Base times height is how you find the area of a rectangle or a square. So base times height, so we multiplied the height, which is 12, times the base, 10 plus h, equals 180. And we solved for h and found that was 5. And 5 plus the 10 is 15, and 15 times 12 is base times height, equals 180. So that is correct, 180. So we would write this answer, h equals 5 inches, because it asks us to find it in inches. And that's how you find h using a figure or a shape, or finding a variable using a figure. So it's kind of like tying in the previous chapters we've learned with surface area and the formulas on the reference sheet. So I hope you enjoyed this tutorial and it made you more comfortable with finding and solving for equations. Go and check out my other videos if you need to catch up on anything or refresh your mind. My videos would be a great thing to do for a review for the FCAT because I'm covering every single chapter in the FCAT on my videos. So that would greatly help your FCAT scores. For those of you that don't know what FCAT is, it's the Florida Comprehensive Assessment Test. And that is just our standardized test that students take in Florida. And it is the last year we're taking the FCAT, actually. So I want to thank you for watching my video, and I will see you later. Goodbye.